Yeah, I'll tell you a little about my background and all. I'm sort of fusing. So this presentation is interesting. I heard I had a big crowd. I heard I had a little more time than I normally get. And so what I tried to do is take a number of presentations I've been doing over the last 6 months and a lot that I'm going to move forward this year. So it's sort of a kitchen sink of a lot of different things that are happening in AI from my perspective. So, you know, and to, you know, to be clear, I'm not sort of a deep neural network person. I observe technologies, I work with CIOs, I spend a lot of time trying to figure out how these affect the enterprise. But I'm also deep enough into this technology, and we'll walk through that too. So really the sort of the narrative, a little bit of an introduction about me. I think that one of the things that you'll see, there's that book called Rebels of Reason. I'm hoping to have galley copies ready for the All Things Open AI. So that means that there'll be mistakes in it. It'll be a non-for-distribution version, but it's a finished first copy of the book. Just to give you a heads up, my last book, the day I thought it was finished, it took another 8 months to get it on Amazon. You know, and that was not because of Amazon, it's because of the review process and the network that you build. And I can, you know, at some point, like writing books is a really interesting sort of narrative. So I'm going to talk about the history and why the history of AI is just incredibly important. And I had this thing that was happening. I was like, I need to tell people what the history means for us as we go through this. And then 2 weeks ago, Monday, I was like, man, now I really, so if you remember what happened 2 weeks ago, Monday, with all the DeepSeek nonsense and everything that went crazy, right? The point is, it just really hit home. And then 2025, like I wanted to use some expletive there, but like I try to be cautious, like holy moly. like 2025 is, if we think the last 2 years have been insane. I want to talk a little bit, depending on the time, what we have, and I'm not normally a hardware person, but I think this idea of GPU starving and what's going on there is reasonably interesting conversation to sort of go through. I'll look at the nods of the heads. If you're all falling asleep, I'll run right through it. But I'm hoping people are really interested in what software engineering means. What it meant 2 years ago when we got Copilot, what it meant last year when we got this thing called Devin. You know, like I'm going to sort of explore that and tell you what I think about this, the tools I've used. And then I have this last thing, which is, we'll talk about, I called it Dear CIO. We wrote a paper on this, probably not going to become a book, but it's an interesting narrative that I'll sort of walk you through. And then if we have time, I'll tell you what I plan for the epilogue for my new book. So I've done a lot of stuff. You know, as Mark had said, this place brings back memories. I go back all the way to Network Service Division, working as a consultant, the Tivoli portfolio, NetView. So if any of those things make sense to you, I spent a lot of time in this campus. I've done a lot of things. I probably have built 10 companies. I always say, my gravestone should say he won a little more than he lost, because I've had some terrible crashes and some stories. There's a book I have that I told my wife, put a kill switch when I die. You can publish it, because it calls out VCs and everybody. But I've done a lot of stuff. If you know Chef, I was the first adult in it, Chef. I sold the company to Docker. I'm considered one of the founders of DevOps. And then I did a 3-year executive stint working for basically Jim Whitehurst at Red Hat. So we hired an executive team. There's 4 of us, and that was pretty interesting. And then over the last year, one of my clients, probably the only client I have right now, because I'm focusing a lot on writing, but is MongoDB, and I focus on their vector database, the Atlas Vector Search. And that's why I kind of know a lot about vector databases. These are my books. If you go there, there's a portfolio. Probably the most well-known is DevOps Handbook, but I did write a Beyond the Phoenix project with Gene Kim. Investments Unlimited is about internal audit and DevSecOps. It's a really small book, but it's and you can get it for $2.90. They sell it now for some ridiculously low price. We have a couple, but not that many. And then my 10-year journey was this book about this famous engineer, most famous industrial engineer called Dr. Deming. And Deming, basically, if you want to know the short version of it, you get from Deming to Toyota to Lean to Agile to DevOps because of this person. I have a thing about AI, the CIO, so I've created a newsletter where I'm trying to literally constantly say, Dear CIO, don't, and I'll talk more about that near the end, but I'm really worried right now that there's a lot of organizations that the pattern is, and we wrote a paper on this, is that CEOs are hiring chief AI officers. Chief AI officers are coming from like CMU or Stanford, which no problem with that. They're hiring a bunch of their students, and they know nothing about hardening systems, or they think installing, basically they think installing Kubernetes is literally just hit a couple of buttons. And there's some real dangers in what can happen to these, and they're already happening in these enterprises because they don't know what they don't know. And so I've been covering that. And just last but not least, this is a second to last shameless plug. Actually, there is no such thing as a shameless plug. They're just plugs. I like writing books so much, and I look through these sort of reasoning models. The guy I write a lot of books with has been writing professional books for like 15 years now. We realized that most people I meet, they tell me, they write a book and they're like, I'll never do that again. That was terrible. I love it. And the problem is the process is broken. So we're really exploring about like all these people I know that have stories that always tell me they want to write a book. We're going to use the AI, we're going to use these things, these processes that this gentleman has built. So anyway, if that's something, if you got a book in you, give me a holler. We're looking for people to be our guinea pigs. Last but not least, this is told, I'm going to be giving out my latest book called Rebels of Reason at, again, Galley Copy. So, the history. So I can tell you a little about this book I wrote. It's kind of interesting how it started. So I like a Michael Lewis-like version story. I mean, I won't say I'm as good or whether you hate Michael Lewis or not, but I like that Bill Bryson or Michael Lewis version, the Moneyballs, and I usually create two target readers. One is my mother-in-law, knows nothing about technology, and in the Deming book, it was basically an operations research expert. And the goal for me is to have them both enjoy and learn something from the book. And I did that in my Deming book. My sort of crowning achievement was I was able to explain Schrodinger's cat to a physicist who liked the way I told it, and my mother-in-law understood it, right? So now I get the same problem here in this AI book, right? I need to tell the history of AI, where I need to basically sort of explain what a CNN does, an example of it is, so my mother-in-law gets it, a combinatorial neural network, and an expert in AI would say, yeah, that was great, John. So what I've done is I've done a fair amount, like 22 books I've read over the last year and a half on the history of AI. And like some of these amazing books, and I'll talk about some of them and some of the people that are involved in this. But it all started in 1943, right? So I had some so this is a paper basically about two guys that literally figured out that basically what a neural network was. They didn't have any computers or anything, but they literally figured out you could use calculus functions based on Boolean logic to literally emulate brain. Right? So this is really important. By the way, the Turing test paper, I forget the exact name of the paper, really points to this. Von Neumann, in his first architecture design, what is the modern architecture for computers, basically points to this paper. He doesn't give him credit, but he points to this paper. Right, so yeah, this is a really important paper. And so what I was thinking about is a lot about benchmarks lately. I know I'm sort of bouncing around a little bit. I mean, benchmarks are really interesting. Like, they're misleading, they can be gamed, I mean, all that stuff. But I think they tell an unbelievable narrative, and it fits really the history. So the first thing is, like I said, 1943, we have this first neural network paper. No computers, just a lot of math. The calculus of the brain, basically. And then 55 years later, in 1998, see where the blue line starts right there. We have this thing called MNIST by Jan LeCun. So Jan LeCun is considered one of the godfathers of AI, right? And he basically does the first really commercial implementation of a neural network, right? And what he does is it's the post office and NCR for reading checks. They analyze like 70,000 handwritten numbers 0 through 9. And they literally build a model, at this point not a deep neural network, but a neural network to recognize numbers. And they call it the MNIST database. And it's usually training 101 for learning how to build a model. At the same time, there's a woman that builds Dragon Systems, Janet Baker. And if you know that story, so I have a really killer chapter on the history of Siri. Right, like a story that I don't think anybody's ever told. It starts with Janet Baker, it turns into Belgium crooks, it turns into all this stuff, even Steve Jobs bouncing into somebody's office and telling them, I demand to put that on that. Right, so you got that. And then, by the way, for the IBMers, right, before that sort of blue line, you had the deep blue Kasparov. Now that's an expert system. So there's two narratives going here on the history, right? Again, this becomes really important too, which is some would call it symbolic or expert systems, or some would call it sub-symbolic or neural networks. So there's two arcs happening in the history, and they're both rising tides, low tide. And the reason this is interesting now is like, okay, if you're about to fall asleep, what you're seeing now is these sort of neuro-symbolic discussions. DeepMind had this alpha geometry where they realized they could use, let's just call them expert systems instead of like symbolic systems, to solve some hard geometry problems. You needed expert systems combined with neural networks. So you're seeing a lot more of this, this sort of combination of the expert system and the sort of what we would consider a neural network. But you sort of go along, and then how many people have heard of AlexNet? A couple, yeah. So this is really important. This is incredibly important here. Because basically AlexNet is another sort of, there's a group, but let's just say Jeffrey Hinton, another person who's considered one of the godfathers of AI, he winds up going to Google, creates Google Brain, does a bunch of stuff. But one of the things they do is they actually come up with an algorithm. It's the first one where they actually use GPUs, commodity hardware, and tons of data. So the thing that really was lacking until you got to basically 2012, which was there wasn't the high-powered compute commodity, unless you were sort of, some lab in New Mexico or something like that. There wasn't a whole lot of data. So there's this beautiful nexus between the right amount, the sort of Goldilocks zone of the right amount of data. The algorithms have been waiting to scream at us to do things, and then all of a sudden you have ability to, and there's a great story about the gentleman who had to go over, this is in Canada, they have to sneak over the border a bunch of NVIDIA GPUs. And then, in 2016, we have the AlphaGo story. Dennis Hassabis, another Nobel Prize winner who is the founder of DeepMind, right? This is a gentleman, this is where the story gets really interesting too to me. I mean, I like stories about people. Dennis Hassabis, at 3 years old, beats his dad in chess. At 11, he's a chess master. At 16, he's at a chess tournament and realizes we're wasting our brain power. Why aren't we trying to cure cancer? Last year, he wins the Nobel Prize for protein folding, AlphaFold, right? Which is the start of that discussion, right? They're just amazing people. Like I like the Michael Lewis version. I think what I'm trying to say to you tonight, if you don't like sort of like having fun reading stories about these incredible humans and the things they do, human good or bad, there's great value in just understanding the history of all this. Because when you get to the reasoning models that came out the last couple of weeks, the reasoning models that came out the last couple of weeks, you like understanding the history and how like DeepSeek is using these hybrids of neural and symbolic, how like a lot of that stuff becomes really important. Certainly 2018 GPT-1, right? And then BERT, and then you got your ChatGPT, and then the sort of the birth. Now here's the thing the reason I picked this chart, which is because in 2022 it seems to go, right? It goes vertical, right? It's going straight up, right? But it went nuts. If you go back to all right, so we had from to 55 years till we get to the first paper. We got another, 70 years till we get to ChatGPT or Copilot. And then literally at the point of June 24 last year, in general, the top models that were out there could do reasoning on a reasoning benchmark at about 60% and coding benchmark at 70%. Right, that's 6 months ago. And now what you're looking at is reasoning models that are sitting high at 77% and and coding at 98%. I mean, humans have never been that good. What's happening in 6 months is, again, I would say we'll talk about what happened in 2020, just this year. This is we got 55 years. Then you have a couple of years of insanity, the ChatGPT. What is this craziness? How can it do this? Is it going to end the world? Are we going to have Terminator? And then in the last 6 months, it's been crazy. And I would argue in the last month, last maybe 2 weeks. I don't know, is it going to stop? I don't know, right? And I don't want to spend too much time, but the quality, the speed, the price, all that stuff, like done. And then, like, I don't know if you follow any. You should follow if you're sort of a DevOps engineer or software engineer, or you at any day in your life you actually have to debug problems in software. You should be watching the SWE bench. It started as a paper out of Princeton. It's basically a benchmark for how sort of agent-based tools can solve problems. Not just write code, but like take a GitHub incident and fix it, and how well does it do. And so just to give you a perspective, this didn't really hit the radar until about last year, March, and a project called Devon came out, invested by Peter Thiel, for whatever you think about that. But what was interesting is this another narrative of open source. Literally, the next day, there were 3 open source projects that were better than this $20 million funded project. Now there's like there's 30, 40, 50. But to give you another perspective, Devon sort of hit the SWE bench, they call it SWE, the software engineering bench, at about 10% average resolution. And then the problems vary, so there's averages, but benchmarks are benchmarks. Right today, state of the art, not Devon, is about 60% on solving complex issues. And I've done it. I mean, I've done like some crazy examples of taking incidents on different projects and literally running some of these tools. And they're not fallible, they're not 100%, they're 60%. But 60% is like, if I get to 60% in 10 minutes, instead of like 8 hours. Does IBM, out of respect, I think the story behind Granite, which is amazing, and we'll talk a little bit more about, I think in 2025, we've proven open source is one. Right? Like it was sort of hints of like, yeah, maybe, yeah, it could be, I'm not sure. Like there's no doubt now. And I think that sort of when you talk about the offerings from IBM, this is not a disrespect for IBM. I've been a flea on IBM's back most of my life. I've built companies, software companies, I've built products on their products. But their slow and steady wins the race, particularly in the enterprise. Right? So there's really good numbers to follow. The fact that, InstructLab, all those tools are getting people like me to be able to build models that 2 years ago would have been impossible for me to build them. I mean, let's face it, my worst probably day in technology was trying to take a Coursera class to learn PyTorch. What did we learn in 2025? I like Chris Wright's, what is open source? Right, this has been confusing a lot of the industry experts about what is open source here. It's not the same thing as what we've known and people are trying to figure this out. I think Chris Wright wrote a really good paper. He's the CTO at Red Hat. I've known him for years. He's a great person, right? And if you look at the TLDR, right, I don't think he got 100% right, but and again, kudos to Granite, right, which is it's got to be open source licensed. It's got to have a reasonable license, like that means all the things, what you can do with it, but it's the weights. So when people talk about an open source project, if you're not providing what the weights they use to build a model, it's not open. And then there's the data, and then there's the scaffolding. I mean, there's just a lot of stuff. And I tried to compile from everybody who's talking about it. There's no one, in my opinion, canonical source right now that describes it, but like licensing, the data. The curation of data. Like if we go back to how many people were following DeepSeek and then they found out like that after the next day you couldn't ask it about Tiananmen Square. Oh yeah, they can't really answer that question. So the curation is pretty important. In fact, the more you curate the data, what we find is, again, these are the experts that I listen to, that it actually gets easier to jailbreak the more you put in the model to stop it from telling things. Right? Model architecture and design, I need to know that. I need to know what was the architecture. Not just the weights, but the layers. I mean, there's a lot of complexities in building a model that just saying, here's the weights is not enough. Community and governance, deployment optimization. How do you deploy the technology? The thing about last Monday, the whole DeepSeek, I hope you're on the page with me, 2 Mondays ago. Actually, was it 3? I don't know, whatever it was. It was insanity. It was one of the most insane days in my 40 plus years in this industry. The markets were crashing. People were telling people to go to chat.deepseek.com, which was a SaaS in Hangzhou, China, that literally in the license agreement, it told you what it was going to collect. It was not hardened. Even if they weren't being bad actors, everybody who signed up got pwned. I mean, that day was, and CISOs, respected CISOs that I know, were like telling people, go try the API. If you don't like that, go grab the model and run it. Well, by the way, the data in the model can jailbreak out too. So it was a crazy day. But people also were saying, well, OpenAI is out of business, Google's out of business. Yeah, like, I've been doing infrastructure my whole life. You don't build a Google or Microsoft or an IBM infrastructure in a week, a month, a year, 5 years, right? And the only reason OpenAI is competing is because the investment they got was to run on Azure. So they've been running on an infrastructure that's been rock solid for all of us for 25 years. So there's just a lot of things that you don't necessarily get where you start making silly statements like, oh, this is going to put everybody out of business. Model evolution, right? Like what happened in 2025. Like if you've been following, starting with sort of the 01, the OpenAI 01, the 03, then you had this, the R1, which was the ZSeek, which used some really interesting ways to do stuff, and we'll talk about that. And then, I've been following the Quen models, which are a lot of the DeepSeek. These are Chinese models as well, that are, And here's the thing, you might have heard of quantization. So with quantization, so the thing that we learned most from DeepSeek, one is that you can do a lot of open source. If you throw millions and millions of people at a problem, it actually can get solved. If you create scarcity, like economic inhibitors to getting GPUs, you might actually get the reverse effects. Smart people figure it out. But the other thing we found out is we've been lazy, right? We just buy these expensive GPUs that use all floating point 32s. And what quantization does at either the hardware level or at the software level, it allows you to basically say, well, you know what? That computation can be an integer on a CPU. That computation can be a float 16 instead of float 32. And like what we found out with DeepSeek, it matters. Now the numbers that they provided, how much it cost, that was all nonsense. That was lies. But the point was, and so I don't care about that. Well, $6 million. They were hoarding GPUs for years. But the real story of that was the big story that we've been reading about quantization. We don't know what Anthropic or Google or how they build their models. And now all of a sudden we found a model that is comparable to 01, and we found exactly, the paper did tell us exactly how they did it. And one of the key things was this idea of basically methodically or algorithmically choosing how you were going to do your computation about, if most people in here had some sort of computer science and you know what the difference what an int is, an int4, int8, is floating point 32, right? They just use some math to figure out when to use it. And they call that in the paper distillation, but it was efficiency optimization, if you've heard of mixture of experts. The theory was that OpenAI uses mixture of experts across the board. They don't just use one model. But again, DeepSeek told us in open source, pretty much explained in the paper, that not only did they use mixture of experts, small language models, large language models, they chose some that were basically floating point 16, some that were 30. I mean, it was just a lot of, how you really want to build these things is have a lot of different intelligence, a sort of an LLM gateway to figure out where to go. That was all in paper. So we went from theory of how we might think OpenAI is running, or somebody who left there kind of gave us over a couple of drinks how it might work, to a paper that showed us this is probably how they did it. And then the whole reinforcement. I'm doing shout outs to IBM. So Arthur Samuel was really sort of the first person. He was an IBMer that came up with reinforcement. He created the first sort of checkers program in AI. And then the benchmarks. I talked about I showed the benchmarks. I think the two benchmarks that are really interesting is the ones that sort of show emergent behavior, or what they call out of distribution behavior. That means it wasn't in the model, but the model figured out how to do it. And the sort of GPQA is sort of a graduate level. So if you had a graduate degree in some sort of science, what is the human capability of solving a Google-like search problem to answer it versus an AI tool? And so you saw some of those benchmarks on the GPI going up to 70%, right? So that means you have a graduate level knowledge, they throw a graduate level, you might have a PhD or a master's in chemistry, but they'll ask you a master's question in biology. How well does a benchmark do that versus a human? And then the ARC one is the ARC is just the opposite. These are normal tasks. How good does it? And actually, those are the harder to get the benchmark. It's the normal, simple things, right? So anyway, how many people have heard about the new OpenAI deep research? This stuff is like, I don't know, man. I try not to get surprised too often. I've been doing this 45 years. This is like insane stuff. And then Google has the deep research, and then the DeepSeek has. So you can build these things on your own, but it's a lot of work, right? So just if you're not following Reuben Cohen, like you should be following, he goes by the RUV. He's got a GIST out there. I'm not going to go through it. I'm trying to allocate my time properly, but he's just building stuff that's ridiculously insane using deep research. He goes in and says, hey, I want a PhD research paper on this, and O3 Mini, hits the DeepSeek button, takes the thing, starts building stuff, including examples of how to build the code, then goes into what's called an instruct model, not a reasoning model, passes it to it, and it not only writes the paper, but if he asks for code, he writes a Jupyter notebook for him. So I did something recently. There was a paper that came out. I always get sort of frustrated about this AI and coding. Again, I've been coding my life. I've been doing coding. I invented DevOps. There's a DEV part of it. Not invented. I literally was one of the person who brought it to America, basically. So like I have empathy for coders. Like I understand there is some beauty and magic in architecture and design and those things. But this nonsense that like AI creates terrible code, it's nonsense, folks. Well, I just showed you the benchmarks. Or now this latest paper, this is another meme that comes out, is we've studied 211 million lines of code. And then we looked at the last 3 months before agentic processes came around and told you why waterfall coding is terrible. They don't say that, but like their paper does. So I'm looking at the paper and I'm like, here we go again, another paper that's going to tell us based on older data. And older data these days is like last month, but like this is data that is like 2023 of Copilot stuff. And I knew it was going to be wrong. I knew it was going to have some fallacies. So what I did is I put up DeepSeek. I gave it I said, read this paper. Because when I would have wasted an hour reading a paper, I knew that it was wrong. Just to be able to respond to it, because I wouldn't respond to it and say it was wrong unless I read the paper. I have some integrity. But I figured, okay, let me read it. I believe now enough that these models can read and interpret papers. I do this all the time. Just to realize whether I should read it or not first. And then I asked it this question about, hey, I think the logic is flawed, blah, blah. And it literally came back in 10 seconds. So my overall wall time for this thing was less than a minute. From the prompt took more time than it did to answer the question. And it said that, that in a agentic program, you can build TDD and BDD and risk controls into the loop, which is how a human would code. So just, humans typically, if they do waterfall, God bless you, but if, that's not the way we do things now. And so to compare that model is ridiculous. So quickly on the GPU, if you haven't followed the GPU starving, on average, a high percentage, almost 2/3 of, or 30%, a third of the organizations surveyed by weights and biases, which is one of the, better surveys for weights and biases, are basically using less than 15% of their GPUs. So they're paying millions of dollars for these cards. And in general, because of memory, connectivity, all those things, they're literally completely starving and underutilizing it. So I think it's worth, if you're an enterprise, to realize or ask the question, even if you're going to stick with NVIDIA, which you don't have to, there are a bunch of APIs in there that you can do things like vGPUs or GPU slicing. You can, like, if you don't measure it, you don't even know. So people aren't even turning on the monitoring. They're spending, $30 million of GPU farms in their enterprise, and they're not even monitoring them. And then there's alternatives. Again, I'll go through the hardware quick, but I use TensTorrent. TensTorrent, like they talk about doing what sort of a NVIDIA GPU can do for 2,000 instead of 200,000. Right? They're new. You get Grok, and then again, there are options of the deep learning models from AWS Lambda are not GPUs. But there's a great paper on how you can use Lambda in an interesting way to put trained data in S3. So again, there's a lot of alternatives where you don't just have to go out and follow the tribe of just buying GPUs. All right, this is the more interesting conversation. So back in June 23, this guy called Swig, I've met him a couple of times. He runs a lot of the hackathons. He wrote this paper. This is one of those ones like, why didn't I think of that? I would be incredibly famous. He wrote The Rise of the AI Engineer. And it's a great blog article. It's out there. And he's a really smart kid, and it's been fun to sort of get to know him. And I've been to some of his hackathons. But then my good friend, Patrick DeBar, is sort of my co-author. I always say he's the godfather of DevOps. I'm this consigliere. He's been really creating this idea about AI native development. So you should literally go out and look at what he's talking about. I'm going to go swath through it really quick. But like this idea of this is sort of like how many people in this room would consider him a software engineer? I would hope all hands, but yeah, no, it was pretty good. Pretty good. That's right. Like this is stuff that like we got to start growing. You can't just make an opinion, in my opinion, to say, no, I won't use it because it's terrible. And I don't say go all in. But if you're not using a scientific mindset of this working or not, you're doing a disservice to yourself, you're doing a disservice to your career, and a disservice to whoever you work for. The agentic tools or agent tools, right? Some of the ones, again, if this is all new to you, you can we'll have a video of this and build like Lane Graph, probably out of the box from Lane Chain is probably the easiest one to get started. I like Crew. I do some tutorials with Crew and Lane Graph. Crew is another sort of agent-based, again, I can set that in motion, that thing where I don't just say, give me this. I say, you know what, go ahead and do this, but like check for this, do this. And this is where I can build in like test-driven development. I can do all that stuff in these things. AutoGen's another one. I haven't really played with OpenAI Operator. And then, again, want to thank, I forgot to do this, Todd, Mark Hinkle, and all the IBM for inviting me here. So this is pretty awesome. So Watson Orchestrate. But this is where it gets really cool. These are the debugging tools, right? Like these are the ones that solve these hard, wicked problems. So Microsoft's had GitHub, not Copilot workspaces. So you literally use this thing. It was in beta forever. Now it's a tech preview. It's buggy, but like you grab an issue in GitHub, it analyzes it, tells you understands the code base in the repo, literally gives you a bunch of stuff. Says, I think it's doing this. It's this, and then it sort of takes the issue and says, do you want to go to the next phase? Yes. I think this is how you should solve the problem. Do you want to concede? Yes. And then it creates the actual changes with the diffs. And then if you say yes, it actually does a pull request. Again, you get to decide along the way. In fact, you get the augment, you're like, ooh, it missed this. Like you can, like right there in the GUI, change it. Cursor is another, that came out last year. If you haven't played with Cursor, it's pretty amazing about the things it can do it's like a helper. It's like having a paired program at your level or better working with you. I like Ada. Ada is really good because she can throw in all the context stuff. This gets really interesting. The problem with a lot of these co-pilots and tools is they don't code the way humans code. Humans usually have documentation. They have Terraform scripts. They have all these different things in their headspace. And these things say, I'm just going to give you a bunch of Java code that I know from a billion lines of scanned. Whereas Ada will allow you to define all those non-functionals and those assets, and it will take that into account as you're trying to figure and create code, because there are other things that matter than code. Klein is another tool. So this is one, me and Patrick DeBar have this workshop we've done for a couple of large customers. We focus a lot on DevOps, how do the DevOps people should respond, but this is an example of where we use Crew to do a DevSecOps problem, just example. And then, so this is the, maybe a little fun part of this thing. So I do this all the time. It's never really failed. Most times it goes really well. Sometimes it goes kind of okay. So we'll see when I say, dear CIO, you say, come on, wake up a little bit. You say, what, John? It's okay? We good enough with this? You don't have to, you don't want to, but some people will. So I told you I'm concerned about, I'm not so concerned about, the ship has already left, the train has left the station, whatever cliche you want to do. So I'm like, you got to stop this. No. And I enjoy these advantages that I'm getting and enterprises are getting, and they are. But I'm really scared about the sort of the magnitude of, we had shadow IT, and what shadow AI could mean if we don't tether it in some way. So I wrote an article I guess it was in 2023, called Shadow AI is Inevitable. And then I told you earlier, a bunch of us got together, part of Gene Kim or the Phoenix Project, and we started worrying about this idea that we kept seeing in people I talked to, where the CEO would hire a chief AI officer, chief AI officer would actually be told by the CEO, stay away from the CIO, don't talk to the CISO. I mean, this is literally what we saw in cloud, but I believe it's at an orders of magnitude more complex. And the dangers are way more complex. So I've been really threading on, we wrote a fictional story about a CIO, a hero's journey of a CIO. They get announced they hired a chief AI officer. He's like, yeah, this is going to be a problem, man. I've seen this before with chief data officers. And then he basically does this sort of hero of inserts himself into the conversation. Because he knows at the end of the day, the first breach, the first failed audit, they're coming to him. They're not going to chief AI officer. And so here's where I start. Dear CIO, prepare for this tsunami. There is a technical debt tsunami. My basic pencil math, napkin math is it's 2.5 orders of magnitude more complex than what we saw with cloud and shadow IT, right? Dear CIO, don't be an Air Canada, right? So Air Canada is like a great story. Now it's like whether it was using GPT-4 or what, it doesn't matter. They internally scraped, they figured they'd come up with a chatbot. Somebody had this brilliant idea of scraping all their internal documentation. I don't know for a fact, but I think it scraped, or was, from what I told, some FAQs. And some of the answers were wrong. So some poor guy's mother dies, and he doesn't have a whole lot of money to go to the funeral, so he asked the chatbot, could he get a refund, or does he get a refunded thing? And the chatbot says, based on some FAQ answer that was not company policy, airline policy, that he could. So he goes, comes back, tries to get his money. Oh, no, we don't do refunds on that stuff. So he spends 2 years in a lawsuit. They lose, when it hits the Wall Street Journal, they lose $500 million in market cap. And the settlement was less than $1,000. There's so many things wrong with that story. What aren't just AI, but part of it is AI. Dear CIO. So what's interesting here is when I wrote that paper about shadow IT and shadow AI, I made an assumption. I said, shadow IT and cloud, right, was like if you had a 100,000 person organization, to the nature of the early cloud days with Amazon, they were API based. In fact, the first SDK was only Java. So maybe 3,000 people in your 100,000 person was really going to participate in this shadow IT stuff. And when I started seeing what was happening with AI, I was like, this is a whole different ballgame. This is like 70% of your organization. So if we look about the damage control we did over 10 years for shadow IT, at maybe 3 to 5%. Can't even imagine when 70% is going down this path. So, and then LinkedIn last year validated my numbers. Right? In fact, the one that should scare the heck out of you, which is 78% of AI users are BYOAI. Bring your own AI. Come on, man. If you've ever managed a responsible infrastructure, that really should scare the heck out of you. These are some interesting stuff. Dear CIO, you should go, people talk about what's the big deal about jailbreaks? In fact, a famous CISO put out something a couple of days ago. I'm like, man, read some of the things that these guys. So one of the things they did is they put a poison model out there. It's like white hat hackers. They put it on Hugging Face. And it literally had the ability, based on some Python code, that it could escape out of the model just by inference. Literally just by using the model and asking questions against it. So it had some code, they call it 0-byte code, it's hidden code, it's a jailbreak. So that if a user downloaded that inference model and they ran it, it would break out of there and then be smart enough to go look for other things. Well, they did it on Hugging Face, and Hugging Face is like sort of a SaaS for running your own stuff. So they did this whole experiment on themselves, they controlled it, they put the model out, they went in, they broke out of the inference, I'm running it on Hugging Face. I mean, no disrespect to Hugging Face, but I don't think the Hugging Face folk in there, they don't know what DevOps is. So basically what happened was, the first thing it did when it broke out of the, where are we at? Yeah, when it broke out of the sort of inference model, it went looking for, am I running on Kubernetes? Great. Is it a hardened Kubernetes? No. This is great. Now I have a whole lot of ways. So basically what they showed is, by running that inference model, you could literally get on a shared customer Amazon host by just running a question against this model. And they've done it to 5 other providers now. And it, there's like, that should scare the heck out of you. Dear CIO, Google wrote a paper in 2015 telling us what it was going to look like today. It's out there. When they were doing scale level ML, and it's pretty valid. In that paper we wrote, I used a lot of this as the fictional version of like what could happen. Oh, I found this paper, and like we used the real paper. But this is what scalable AI looks like now in most banks and insurance companies. And Google just happened to write a paper about it 10 years ago. Dear CIO, you run it, you own it. Like, so I'm not picking on Bedrock, like it's as good or bad as any other one, infrastructure. But like what this picture tells you and tells me, and my evidence is that when your company writes a chatbot or a copilot, anywhere from 80 to 90% is, guess what? Plain Jane infrastructure. It's I&O, it's middleware, it's things like Kubernetes. So like if we're just thinking that all we have to do is worry about this sort of AI solution, and we're thinking that all that stuff is different from what we've classically been doing pretty well in the DevOps era, like we're in for big trouble. Look at some of the ways that we've relied, like the OVAL, the STIX, the CVEs. NIST has been doing, I think, not a great job. I will say OWASP, we'll talk to in a minute, has done a really good job. MITRE is catching up really fast. So if those mean something to you, these are the ones that the government goes to figure out how to deal with breaches and what vulnerabilities are, and CVEs and what their impacts are, right? There are new opportunities. There's 0 days. Embeddings are like a whole nother cascading risk category. If I know that you built your own model, and I know what embedding you use, and used an open source embedding, these are just highly dimensional vectors. I can literally figure out what's in your model. So if for some reason I know that you use a certain embedding model, I know how your highly dimensional space is, the vector, either your RAG or even your model. I can reverse engineer a lot of your model just by knowing what embedding you used. This is a whole new domain. You don't have to answer my dear CEO, but dear CEO, pay attention to what's going on. I'm not telling you to stop. And those new Stanford grads, they don't know that these are problems. So OWASP, the April 11th paper is fantastic. There's an older one that's not as good. They go detailed, they integrate with MITRE. It will tell you state of the art. And here's the sort of top 10 LLMs. Again, you'll learn a lot about vulnerabilities by just reading this paper. The other thing I would say is, I don't have the links to it, but if you send me some information, I'll send. I track the bug bounties for AI. That tells me really where, like the more money they're paying, that's the real things as a CIO I need to make sure my organization is worrying about. Epilogue, all right, I'm at 43, still a couple of minutes. So how many people have heard of John Alspar? Nobody. Oh, one. All right. He's been a mentor. He's most famous for telling the first story about like sort of scalable DevOps. It's called the 10 deploys a day at Etsy, Flickr, I'm sorry, where like everybody I was in the room, it was like, you can't do that, it will ruin humankind, you can't deploy that often, right? So, but he's been into like a lot of sort of cognitive science, behavior science, adaptive capacity. And when I told him I was writing the book, he was like, you need to talk to my mentor because he's going to want to talk to you. And it really started me on this journey about this idea of what I'm calling the philosophy of AI. And this is like crazy land stuff. I'll be done in a few minutes. But if this is something you're interested in, I really started doing some research on what would we do if we started thinking, like how could we like get our handle on this stuff? And I don't care about AGI. I do I don't worry about AGI, right? Like, is our system's going to beat us? Is it going to be turned out? Like, it's a nonsensical debate, in my opinion. What I do care is, do we understand the science and philosophy? And a good friend of mine said to me, to sort of understand science, you need to understand the philosophy of science. Anybody in this room disagrees with that? If you do, leave. But what we're not saying is, to understand AI, you need to understand the philosophy of AI. And I know this is heady, but no scientist would disagree with that last statement. In a sense, we're supposed to be sciences, the often computer science, which never really is, but we are. So then, we should start thinking about the historical argument. And this works really well for my book, by the way. but the point being that, the historical argument should, what is the history here? How can we, you can't understand science if you don't know what Archimedes did, right? There's certain, if you don't understand this, Francis Bacon, that's a philosopher, but, the scientific method. We need to have that. I know I'm getting heady and, this guy's going nuts. But we also understand the epistemological argument, right? Which is, and I'll go through this really quick, we need to really think about the science version of what AI is. Let's not just have these arguments, whether ASI or AGI or your AGI. No, I'm not, it ain't gonna, the world's gonna end. No, it's not, The historical context. What is intelligence? Let's start with the fundamentals. What is intelligence? There's, in that book of 20, there's a couple of really good books there that really explore what the science over the last 200-300 years, you could go back to Aristotle, Plato. Can machines think? It's an interesting question. It's not an AGI, is the world going to end, or are we going to have Terminator? But a nice science debate on the philosophy of AI makes it worthwhile, and this is the part. So how many people know who this guy, and I wouldn't expect anybody to know who this is. So this is the most interesting character in my book. His name is Walter Pitts. Right? And I have a lot of stories about guys, but nobody's more spectacular than this guy. So at about 12, he's comes from a broken home, out of Detroit. His father's an alcoholic, has no formal education, speaks 3 languages, including Sanskrit. He gets chased by a gang, hides out in the library for some time until he figures out, not just one day, 3 or 4 days, because he figures he has to wait till the gang is going to leave. He decides to open up Bertrand Russell's Principia, 11-volume mathematics, sends a letter to Bertrand Russell in Cambridge and telling him it's wrong. He thinks he's talking to a PhD student, invites him to Cambridge, no conversation. His name's Walter Pitts. He was the co-author of that first paper. Turns out this guy probably, if you do your homework on this guy, so he literally becomes an important part of sort of cybernetics, all these things that are incredibly important. And, in the end, he was so brilliant, but he was also hung out with, Jack Kerouac-like characters. They drank alcohol in the 50s. Oh, my God. They actually, had parties and listened to jazz, right? This, terrible, terrible stuff, right? The point is, so here's the punchline of the whole thing. At the end of the day, he's one of the, people who know who he is know he might have been one of the most important 20th century scientists. Not just in America, but in the world. And there's an argument to be made, and people have made it. But they don't know what to do with him because he's kind of a terrible person, so they basically give him an associate's degree. That should just make somebody laugh, right? Some of the things about philosophy, understanding where these things came from, Turing. I spent a lot of time on Turing. I have 2 chapters on Turing. A lot of, and then again, Walter Pitts is this amazing human. This is an interesting story too. Probably nobody's heard of Norbert Wiener, cybernetics. So it turns out the real champions of the way everything should have looked and have been completely different before people, I call them the Beatles of experimental epistemology, or you can call them the Beatles of AI. They are literally at MIT in the sort of 50s, 60s, so probably 60s, literally creating this room where they put the sign experiment. They're basically creating what should have been AI. AI should have been called cybernetics. The guy who coined it was a petty person, John McCarthy, and so he didn't want Norbert Wiener to get the credit, so he called it AI, which he admitted was a terrible name. These 4 people, it turns out this is sort of the weirdness in me, but the one guy, the Norbert Wiener's wife, was crazy, and she had all these fantasies that they were doing nasty stuff. So she was the Yoko Ono of this band. I probably shouldn't torture you with what's the difference, why AI and rationalism, empiricism, but I think the thing I think you should understand is you understand basic logic. If you think about expert systems as deductive reasoning, and this is an oversimplification, if you think about neural networks as inductive reasoning, the thing we haven't solved about thinking machines is what abductive reasoning means. And abductive reasoning in the most simplest example is the Columbo. The Columbo can figure out, like, it's probably you who murdered because that jacket and your shoes are muddy, and, like, you know, it's that sort of instinct based on logic, based on all those things. Yeah, that's me, and I hope you enjoyed my presentation. Sure.
So I think we have Nathan, do we have a microphone to pass around out there, or should we pass this one around?
Yeah, give me one and do that.
Oh, okay. Oh, there's actually one here.
Yeah. Okay, good.
There's one as well.
So I will say I only have about. All right, so I know about AI, but I can't turn the microphone on. So here, what do I need? Oh, there we go. All right. So yeah, there we go. I only have about a total of 50 books, and there's a lot of people in here. So I will say this: the people who ask good questions, you get first crack at a book.
You want a question for John?
Yeah.
Okay. Yeah.
And then I think you're next over there. Hopefully I'm trying to.
My question is, given your experience on people adopting DevOps and how that has gone well or poorly, and then everyone moves past it eventually, how do you kind of see people adopting AI well or poorly, and then kind of moving on and pretending we've figured it all out?
Yeah, I mean, I think there's a lot of correlation or corollaries between what happened in DevOps. When you think about DevOps, was this problem that we were already siloed, right? So the original picture my good friend Andrew Schaefer created a wall. You had Dev, you had Ops, and just sort of throwing it over the wall. Let's smash the wall. So there was this siloization where we realized there were some problems by just putting Dev in like San Diego and putting Ops in New York, or right. That parallels my dear CIO problem. Is that, like, let's just be clear here. Whether it's AI, whether it's DevOps, whether it's C programs, or it's a mainframe, IBM mainframe assembly programs, fundamentally, it's network, compute, and storage. That's what it is. So when we forget that, and we think this is special, you know, one of the biggest problems in the early DevOps days was we created DevOps teams, right? Oh, no, that's not what we were talking about, right? So I think the parallels there are like, let's realize that this is network, compute, and storage. This is an infrastructure problem to solve. The behavior patterns of how we do things should be controlled. So DevOps taught us that if we were methodical about the way we deliver software, we deliver software better. If we're methodical, and by the other way, include everybody in the conversation. I mean, DevOps was a metaphor not just for Dev and Ops, it was for Dev and QA, it was Dev and marketing. It was to get everybody that you could possibly get in the room to figure out how to deliver a service. And my fear is, and I see evidence of this, that right now, like, we're building AI systems completely orthogonal to that process. On purpose, CEOs are like saying, no, I don't want you near that group. So yeah, so good questions. You get first book, hey. Yeah, oh, well, I think that gentleman was second, then we get you third. All right, just to, okay, we get them.
Across the room, why don't you just say your question?
Yeah, just yell, scream it, and I'll try to repeat it. You had your hand up, right? Yeah. I'm trying to do this in order, right? Yeah.
Yeah, so and maybe it's just philosophical in the conversation, but when you're talking about open source, your first line item, licensing is, you know, the open source. The rest is really just transparency at the end of the day. Is that?
You know, again, I think I don't think we actually have industry absolute clarity on what open source means in AI, but I would say it's a little more than transparent. I mean, transparency is a big part of it. But, like, if you're going to give me all the code that you use to build whatever this thing is, your model, your inference, like, it would be nice to give me some source of your models, your weights. So that's an asset. I probably, one of the problems with the DeepSeek model, which was everybody was, how this is awesome. They give us the code and they gave us the weights, but they didn't give us the data. And this is a shout out to IBM. IBM gives you the data. So without the data, how you train the model, you're starting from scratch. You don't know what made that model good. So I think those assets are more than transparency. But I don't have a sort of clear definition. And I don't think the industry, and somebody can correct me if I'm wrong, has done a great job of clarifying. Because I think even the infrastructure, in the classic open source, we sort of default to transparency by looking at a GitHub project, and we can see the Terraform and the sort of scripts and all the things that build it and the Docker files and all that stuff. And so that gives us sort of some sense, but that is more transparent. But like I want all those things. How do you build a scalable implementation of this model? Like don't just, oh, you figure it out. A good question. So if you want a book, just line up to. Let's go like into a certain sense of order. We got you, and then you back there. All right, go ahead. And then you'll be next. Yeah, you.
Okay. So you mentioned about Pitt's no formal education, kind of training himself. Started as a selfish question for myself, but then I thought about my kids. So thinking about where we're at, the massive explosion you mentioned at the beginning, what kinds of education, training, things for the next generation do you see?
Yeah, so this is a good question for me to ask. I one time, I don't know if you know, Sidney Decker is one of the more prolific safety. He does like safety analysis, critical complexes.
Be sure to repeat the question back. So we get
Oh yeah, so the question about what kind of education should we tell our kids, the short version, right? So here's the interesting, so I'm lecturing to his PhD students, and they, so at the end, they're like, so where'd you get your degree from? Where'd you get PhD? I'm like, dude, I'm lucky I got out of PS 105 in Brooklyn, alive. So I don't have a formal education. Now my kids, my oldest son went to Georgia Tech, got electrical engineering, like that was going to happen no matter what. And my youngest son's going to supply chain, he's not really into math. I think math, like I think, right now, it's like math is like statistics, but math, I mean, like I just think, there's sort of the Asimov, like I can get real meta here, but like if you talk about the Foundation trilogy where it turns out the Sadal guy is the only guy who can run the computers, I think the math people are going to have these advantages that we don't. Like even Reuben Cohen is like a math guru, right? So, and who's the guy I say everybody should follow. So I think just hard math. And if they don't like math, then like statistics, maybe a lighter weight version of that.
Yeah.
So in regards to responsible AI, if we can oversimplify it into the can we versus the should we, do you feel the should we, responsible AI governance, is growing at a commensurate rate with the can we, or is it being woefully left behind?
Well, I mean, just, not to, I'm a fan of Google in a lot of different ways, but they just literally changed their sort of do no harm for AI, like last week. Right, so I have a chapter. I'm actually going to take it out because I'm like, I want to have 40 chapters, and I just wound up 41, and I just think there's something about numbers. So I had a chapter called Stop Killer Robots, and I'm going to publish that as a supplementary. But I talk about this whole Stop Killer Robots, the history of it, where it started. Even Elon Musk, wherever you fall on him, he's a big part of that. It's the Wild West right now. It's like worrying about AGI. I mean, this is an important thing to worry about, responsible AI. I think explainable AI is a really interesting. So if you start following that thread, you get more sort of pay dirt out of who's trying to be better at explainable AI. I think graph RAG is an interesting way to think about that, not the whole solution. So just give you some threads to go on. But it's a really good question. All right, so hold on there. Who was somebody here that was next back there? So I'm losing count. I think let's say it was you, and then we'll get you and you. All right.
As enterprises start adopting AI models, now it's a little bit of a scaling of the wall for the enterprises. But once they adopt it, what happens 3-4 years later in terms of the equivalent of AI tech debt? Like all these models, as they decay and age, what's going to happen?
Yeah, I mean, again, that's the way you have to look at this problem, right? Oh, I'm sorry. Yeah. So the question about, as we build all this AI stuff in the enterprise, what about the tech debt? That's why I talk about the tech taxonomy, right? But the way you need to think about this is, I'm glad you asked this because this is interesting. I interviewed a CIO late last year from a healthcare company. And, he said, really younger guy, really bright, I think has a great future. But he said to me that, the way I think about AI is not an ROI based. Everybody's screaming at me like, we're going to make money, this is do or die. He said, the way I think about it, and you know if it's 3 years, 5 years, or 10 years. But he said, I think of it in two things. It's talent transformation and innovation transformation. And so the beauty of that thinking is he's got all sorts of developers. He's got new kids coming out of college. He's got 30-year-old Java developers, right? And he needs to get them all on the same plane from the way they think about innovation, and so that's his talent transformation. So I think the executives that are thinking less about the short wins and how they get an organization to change, to adapt to a new way of thinking. And right at the end of the day, if there's still people like screaming and hollering about like, I can't use that nonsense cruise stuff or Copilot, then maybe they're not in the right place. But like what I want as a CIO, I don't want my like 30-year-old Java. I don't want to get rid of my 30-year Java programmers. I want to be right in the thick of this. But I want them in the thick of using these tools, understanding what innovation looks like. We got somebody over here. You got to remind me who it was. It was you, I think. I think it was you.
Mine's like a 1.5 part. The first, like, kind of softball one is, where do you think AI is on the hype curve?
Oh, it's like there's no chart to chart it. There's, no, I mean, but that's the problem, right? Like, step back. I mean, the reality is, it's incredible reality. You know, that paper I analyzed with the deep research, that's reality. I've coded more, so I started my career as an IBM mainframe assembler coder, right? Which was such a gift to me because I can look code, any kind of code. Like if you've written like, millions of lines of IBM mainframe assembler code, like there is no language. And then at one point I did Prolog and but the point is that I've coded more in the last 2 years than I probably coded, except my first 5 years in the industry, I've not coded. It is so easy for me to prototype examples of ideas, and I'm fearless now. So that's not hype. That's reality. The hype is the people that are swathing either anti or it's going to do the pontificators are talking about, like Ethan Mollick, like I'm going to beat him. I'm going to beat his book, with my book. And like he's a good guy, he's in academia, but like he swats all these things about like just sort of like nonsensy stuff. Like, like write the code, run the code, do the code. Don't just like build a model. So there it's both, right? I think there was somebody over here. Let's go with you, I think.
I had just to follow up on some of your Dear CIO stuff. You were talking a lot about the security and vulnerability side, but in my mind, I think even worse than that is the legal ramifications.
Yeah, absolutely.
Is that? I'm just trying to figure out if that's really bubbling up in the Fortune 500 C-suite, or if they're just trying to push it off.
So let's step all the way back, right? So that book I wrote called Investments Unlimited with 9 other people, right? That was, this guy. And he's staying at Mark's house with me tonight. So this is I love Todd. So the question is, like, I talked about, like, sort of vulnerabilities and risk and sort of, but what about legal? And then there's other things, right? I think what's interesting is I wrote that book called Investments Unlimited about sort of internal audit, how we can build pipelines to create immutable evidence, attestations and all that stuff. And I think, when I think about like what we're doing and sort of like how do we, here's the thing, right? Like when you get old, you start forgetting. Like that's like an interruption, like I forgot what I was going to say. But what is the most important? So one of the things we ignore in DevOps, we created DevSecOps like 5 years after we created DevOps. And then in DevSecOps, we said, oh, it's all solved now. But what we didn't do, I always tell people, IT sec is not IT risk. Like let that sink in. Because IT risk is basically your internal audit. In the banking industry, it's 3 lines of defense. And there's a second line that actually is the liaison between the owner, which is usually a technical person, and the person who's going to do the internal audit, which is the third line. And people in most organizations are like, those people are terrible. They waste like 6 weeks out of our year, and it's just I have to lie to them. But and it turns out, I'm telling you, I spent times in large banks, and like you can't imagine the lies the first lines make up, right? There's banks that literally have grabbed a bunch of the IT pipe-hitting technical people to put them in second line because they don't trust. I know banks that have like 70 people in second line that shouldn't be there because they don't trust what first line says. But like, what is the point of all that? It's to make sure that you don't lose Equifax $5 billion market cap in one day. It's protect the brand. We never use that we never say those words in IT. So yes, and like if you look at Adobe, follow some of their presentations at Gene's conference, they talk about bringing legal in, risk. They have a really good, this is the way they're sort of manifesting a systemic way to do AI. So take a look there. If you can't find it, ping me. I'll point you to the. I'm losing count on who's next and stuff, so I just give. Go ahead.
No, it's a follow-up to actually
Okay.
it's privacy and policy, because especially in Europe, where you have a much more stringent policy on
Right.
privacy and also now an AI framework policy, how that is going to impact this on a global scale.
Yeah, well, the policymakers, like, this has gotten really hard, right? Like, because the policymakers are like, behind NIST, and NIST is not doing a good job, right? So a lot of the policy stuff is sort of swaggy stuff where they don't understand technology, and even if they got it perfectly right last summer, it's all wrong now, right? So, I think the real key to figuring out this, like, what do we do? We've got to use some common sense. We got to protect the brand. And, and at the end of the day right now, like, I'm going to be perfectly clear. If your data is sensitive enough to kill people, or people who get killed, or you could lose like billions of dollars in market cap, then you probably shouldn't put anything other than your internal infrastructure. I hate to say that because I've been pushing cloud for like 88 years and how it's not that dangerous. But like, these models we still have no idea. If you start following the jail, I'm gonna give you a really good example. This one scared the heck out of me. It was like end of last year. So like the adversaries, so the adversaries is using AI to be adversaries, right? First off, let's be really clear. They've got the same tools and they're basically getting better and better at being adversaries. What they're figuring out is, like, companies are disclosing how they're building their chatbots and where the sources are coming from. And some of them are stupid enough to put external sources. And so then what's happening is the adversary is like, oh, I think Vanguard, and I didn't say Vanguard, but like, it could be any insurance company, gets some document for their audit GPT for orders, and they get that document. So I don't even have to break into their firewalls and stuff to get in. I could just put 0-byte jailbreak code in that document, and when somebody does an inference, I get control to do a bunch of nasty things. If they have to get into your organization to get a document, it's much easier to find a tier 3 controlled asset than a tier 1. And typically some document that why would anybody put that as a tier 1 asset? Like, if you look at banks, right, they classify tier 1, like funds, anything to do with funds in a bank is going to be a tier 1 asset, right? Any code that deals with like what happens with your money, right? Like, but some document that tells you how you should do things on Wednesday and whatever that gets written by a rag, that could be a tier 3 asset, and they're not protected. So the adversaries know this, so they can break into your place, go looking for it. So yeah, I think right now, I hate to be one of these people that say this, but given the unknowns, get the expertise. The open source models are incredibly powerful. Figure out the classification of data, the things that should not. The smartest companies right now are really making everybody in the company take an HR. That nasty stuff, like I've been independent most of my life, but every once in a while I work for a big company where I got to take one of those HR-driven once-a-year things, and you can't fake your way through it. You got to answer all the stupid questions. Companies are making people take that on AI right now. So now they've got the checkbox, you took it. So you can't do the do now, ask forgiveness later, right? Like, you were told, these are the things right now we know you can do. These are the things you definitely will get fired if you do. And you check that box, you go, oh, I didn't know. And these are the things, if you have a question, come to this board. And that's a really good policy, because in cloud, most companies didn't do that. So most people opted for, like, that guy's telling me to do something, this woman's telling me to do this, that group tells me I can't, I've got to do this, I'm going to do it, I'll take the blame on the loss, take the win if I get the win. So, yeah, good question.
I hate to do
all
this.
right.
It's 8 o'clock, so
All right.
let's go ahead and wrap it up. John, thank you very much.
Sure, yeah.